Right, we're at 5 minutes past, and I suspect we'll have more join in due course, but I suggest we kick off today's discussion. Good afternoon and welcome to this webinar, which is titled Small Language Models Explained. I think looking across the screen, I do spot a number of familiar faces and indeed familiar names, but I'm Usman Ikhlaq, Program Manager for Artificial Intelligence at techUK, and I'll be chairing today's webinar discussion. techUK, as many of you know, is the UK's technology trade association. We have over 1,000 members, majority of whom are startups and SMEs, but we also do have a number of large organisations in membership too, some of whom are on this call. Before we kick off, I do want to provide some context in terms of the AI Leader Series and where this particular webinar sits within that context. So we launched this new series back in January. We're looking to really explore cutting-edge AI tools and developments, trends, ensuring that our fingers are on the pulse and that we convene industry leaders and thought experts in that regard. So last month we had a webinar, or in February I should say, on agentic AI. This one obviously is on SLMs, and we'll continue to sort of look into those cutting-edge tools throughout the year. So before we do kick off, just a few house rules. This session, as all of you know, will be recorded. I'm going to ask attendees, if you're not on the panel, to keep your both your cameras and microphones off to ensure for a smooth discussion. And please do use the Q&A, so that the chat function, I should say, for any questions, and we'll field some questions towards the end of today's session. I'm delighted to say that I'm joined by a stellar panel of experts, which include Dr. Juan Bernabé-Moreno from IBM, Grace Adamson from Snowflake, Andrew Burgess from Greenhouse AI, and Ed Kelly from Databricks. And I may just pause for a second to allow each of them to introduce themselves. Juan, should we go with you first?
Hi, everyone. Juan Bernabé-Moreno is my name. I'm the director of IBM Research, responsible for UK and Ireland. And at IBM, we are extremely committed to small language models as well. So it's going to be a very interesting discussion today.
Thanks, Juan. Looking forward to your insights. Andrew, should we go to you next, if that's okay?
Yeah, thanks, Usman. So my name is Andrew Burgess. I'm an independent AI strategist, ethicist, and part-time data scientist. So a lot of the work I do is developing AI strategies for organizations, ethics frameworks, etc. And I'm also an author as well. So I wrote a book called The Executive Guide to Artificial Intelligence, the second edition of which was published in the summer, available from all good booksellers, as they say. I'm also on the AI and Data Leadership Committee at techUK as well, and on the Data Ethics Working Group as well.
Thanks, Andrew. And yes, we'll allow that promotion on this occasion. Thank you. Grace, should we go to you next? Grace from Snowflake.
Hi, everyone. My name is Grace Adamson. I work specifically on AI go-to-market for Snowflake in EMEA, but also am helping lead a lot of our responsible AI policy work and efforts here, and also have a vested interest in small models. So I'm excited for today.
Thanks, Grace. Glad that you're here. And last but not least, Ed, should we go to you next?
That's great. Hi, everyone. So my name is Ed Kelly, and I lead our efforts at Databricks in the UK and Irish public sector, helping them to deploy Databricks and adopt ML at scale. So like Grace, got a vested interest in small language models.
Thanks, Ed, and thanks all. Really grateful for each of you taking the time to be on this panel. And as I mentioned from the outset, we'll certainly take some questions at the end of the session. So please do, throughout this webinar, populate them into the chat function, and we'll take them at the end. Brilliant. Well, we'll get straight into the discussion itself. In terms of small language models, I think it goes without saying that LLMs are well known, very much have become a cornerstone of AI trends and developments in recent years, but we are seeing those cutting edge tools really come into focus and come into view. As I mentioned, agentic AI is obviously something which we've heard a lot about, and techUK did run a dedicated webinar, as I mentioned, some months ago on that, but also SLMs. And so we'll obviously deep dive into this particular subject matter, but perhaps I might kick off by asking each of the panelists to maybe help us to make sense of what SLMs are. What does it mean to you? How do you define it? How do you say it differs from large language models in some ways? And why they're gaining traction. So I'll put that to the panel. Juan, am I okay to go to you first, if that's okay?
Sure. Yeah, yeah, happy to go first. I think the definition is quite probably is quite intuitive for everyone, right? It's like we've been witnessing kind of the trend of having larger and larger models trying to do everything, and trying to also develop potential features that not everyone needs, right? And depending on the business context. And what we see as well emerging is these smaller versions of large language models where you have way less parameters, right? Ranging in the millions to few billions, right? 7, 8 billions, where you have models that are usually very specific to a particular domain or very specific to a particular task, or kind of a distilled version of these large language models with a very particular purpose. For example, I don't know, it's like to speak a child language, right? Or just to make sure that, I don't know, you can run these models in environments that are out of reach because of the computational requirements for large language models. Think edge computing, for example, right? Or where you actually you have a business case behind. And large language models, if you want to really use them with your own data, in your own setup, don't tick the box because of their consumption in terms of cost and energy, right? And computing power and so on. So the trend, the large language model trend, has created a space for smaller models, more dedicated models, exhibiting the similar performance to large language models, but with some to me, some very important features in the context of enterprises, like, for example, so better control of the data that they are trained on, more, how can I say that, more targeted space for the use cases that you're going to be using them for. And what's very, very important as well, you know, always with this putting AI at work in the context of an enterprise filter, which in the end is about, you know, a cost benefit setup. So that's a bit of my attempt to justify the need or what they are, right, for small language models.
Well, thanks, Juan, and I think some interesting points. And I think it's quite fascinating to hear examples of enterprises, you know, deploying SLMs to complete tasks which, you know, in the past maybe completed by LLMs, and how they're sort of finding that, you know, there are, you know, equally as effective, but also some interesting outputs stemming from that, and also addressing some concerns they may face with alternative models. So thank you for sharing your insights. Grace, I'll put the same question to you.
What we're seeing is a movement along the AI maturity curve. So when everyone first started looking at AI, it was, okay, give me the model that has the most capabilities, the largest context windows, and then let me play around with it. But now that people are moving a little bit past that experimentation phase, they're realizing that each business case really needs a different tool. And so people are now becoming more mature and trying to find the right model for the right use case, instead of just thinking, okay, I just need to get my hands on a large language model. We're really seeing a lot of interest and adoption in smaller language models because they are cheaper, less energy footprint if you're looking at ESG metrics, security reasons, and you can train them on business context data that can make them highly accurate and performant. And so I think now the interest in small language models is picking up, even amidst all of the still pressure I think people feel today with the latest, you know, big model announcements to only use the latest and greatest. No one got fired for buying IBM, I believe is the phrase. But I think we're becoming smarter about looking at actually what will give me an ROI, what is actually most effective and cost efficient and performant for my business.
Thank you very much. And I do hear that concept of, you know, thinking big but acting small, and identifying one or two use cases that you really want to pursue. So thank you for sharing that. Andrew, I'll go to you next. I know that you've done a few pieces of extensive research on this, and I know you've submitted a few pieces for our own campaign week, which I'll get onto probably at the end of the session. But we have actually launched our own AI campaign week for this year. So I'll hand over to you, and keen to hear more.
Yeah, thanks, Usman. And yeah, just to follow up on Grace's point, the main thing around small language models is the use case you're using it for. So a good analogy actually, if you're just popping down to go in the Ferrari, in a lot of cases, sorry, are we? No? Okay.
Sorry, Andrew. I think you mentioned Ferrari and we lost you for a second.
Okay, I'll talk a bit smaller then, slower. So the analogy I was talking about was if you want to pop down the shops for some milk, then you don't go in your Ferrari, you go down in your Fiat 500, and it's the same idea. So in a lot of cases, small language models are good enough for the task that you want them to do, and you don't need to have the big engine, the heavy energy usage models to do that. Just to kind of pick up on Juan's point in terms of like the types of small language models as well. There are different ways of creating the models. So first of all, the model can be born small, so you can have small architectures anyway, which is probably the most common use. But you can actually take the larger models and shrink them down to become smaller models. And there's a number of different ways of doing that. You can, first of all, you can quantize them, which just means making them less precise. So a lot of them will have like 16-bit precision within them, and you can take them down to 8-bit and 4-bit, and that shrinks down the models quite dramatically. You can also use a method called distillation, and the best way of explaining this is you've got like a teacher and a student. The teacher is your large language model, and the student is the small language model. And the small language model learns by asking lots of questions of the large language model, and it learns how to answer the questions in the right way. So that's another approach to do it.
Brilliant. Thanks, Andrew. And last but not least, Ed, we'll go to you.
Thank you. So I think, unlike Lord of the Rings, there isn't one ring to rule them all. So I think certainly with what we've seen at Databricks is there isn't one model to rule them all. So what we've seen a trend is towards what we call compound AI systems, where different SLMs are daisy chained together to perform a specific task. And obviously that has the overall advantage of improving performance and really good for industry specific applications such as in health or in financial services. So I think the AI marketplace is diverging in two directions. I think the compound AI is one direction, and then of course backed by small language models, and then there is obviously the large language models, which we all know about.
Brilliant, thanks, Ed. I think lots to unpack from what each of you have just sort of talked about. But thank you. I think we're good for time, which is always a good sign. So I think we can move on to the next segment of this discussion, which looks into those specific opportunities with respect to SLMs. So as we covered, in the session so far, they're evolving very fastly. What are the biggest opportunities you see that they could potentially bring? And obviously, you've touched on a few emerging trends, but keen to learn a bit more on that. So, Grace, am I okay to go to you first on that?
Are you talking about emerging trends in small model adoption or usage?
Yeah, I would say both. So what are we seeing on the horizon? What should we potentially be aware of when it comes to adoption? Yeah.
I mean, absolutely. With hand in hand with compound AI is agentic AI, which is the hot topic of the year, and using small models that are highly specialized as part of your agent framework is definitely something that a lot of businesses are looking at, because as we talked about, slightly more efficient, can be highly specialized. And so chaining those together in order to effectively be able to have the right industry knowledge, the right business context, and still give the right output in the context of an agentic framework is definitely something that's, I think, on the top of a lot of people's minds. So I would definitely pay attention to that. And then I also think another a big thing that people will start thinking about is deploying smaller models on devices and what that means for applications and for users. So, and compliance, there's a whole host of questions, but we're moving from almost, think of, your personal laptop. So it's sort of the same in AI, where we'll start seeing these models not just be hosted in big enterprise contexts, but also potentially more personal contexts as well.
Definitely, thank you. And I think we are seeing this further democratization of AI. And I think as that continues to happen, I think this sort of notion of the convergence of these AI tools, how they sort of work together and complete different tasks, I think that's a sort of interesting discussion in itself. So thank you for that, Grace. Andrew, I'll go to you next, if that's okay.
Yeah. Just to continue on that theme, I think, one standard use of large language models is in a RAG approach, where you're accessing a corpus of data, you're retrieving information from that to be able to answer a question, typically for a chatbot. And there's a number of different steps in that process, and the early steps of that don't need a big meaty model to do that. Just doing the retrieving part could be a small language model piece, whereas once you've retrieved the context and you want to get your really good answer, then maybe a large language model is more appropriate. Also, to take that a stage further, at the other end of the scale, we've got reasoning models, and these are very capable models that have reinforcement learning built in, able to do much more step-by-step processes. And one of the things that I've been working on with some clients is actually to use the two in combination. So the reasoning models can do a lot of the pre-processing of documents, for example, particularly if you've got a RAG approach. So you can use your reasoning models, but just once, to create LLM-friendly or SLM-friendly corpus of data. And then you only need the SLM to access this better corpus. So, and that's the bit, the SLM bit is the repetitive bit where you've got, energy costs and token costs as well. So putting the two together is I think this is a really good approach, actually. So it's not, just when it's not one model for one thing, it's how do we actually build the pipeline that makes the best of all these different technologies.
Thank you. Ed, I'll go to you next.
Yeah, I think building on seeing SLMs deployed in embedded systems and IoT devices, particularly in healthcare applications. So for that early preliminary diagnostic support, maybe running on a personal device, and then feeding that information if something is detected to a healthcare professional for review. So I think we're going to see that really take a grip in healthcare in particular.
Yeah, thank you. And I think that's a really interesting point, because I think when we think about applications and I suppose where the government is, I think with the announcement of the action plan, very much looking into how these cutting edge tools can be used to improve the provision of vital public services. So it would be interesting to see how SLMs are deployed in those particular areas, thinking about health and social care, but also education, ultimately to sort of improve the lives of citizens. So yeah, that's a really interesting point. And last but not least, Juan, we'll go to you.
Yeah, no, I would like to build upon a point that Grace made at the beginning, which is everyone's now trying to try this model, that model. If my model is smaller than yours, I feel like my model is not right. All these things. But we shouldn't forget that the real value of Gen AI is going to come when enterprises, right, institutions, they integrate their own data with these LLMs, right, or SLMs, right? And I think it's very, very important to think in this context, because otherwise everyone is going to have the same data. Everyone is going to have the same competitive advantage. But if you really want to unlock the power of Gen AI in your own company or enterprise, you cannot disregard your own data. So you're going to come to a point where you need a mechanism so that you have a trusted model, a small model with all the performance benefits and so on. Transparent model so that you know which data is being put there, so that you don't take any risks in terms of copyright, in terms of licensing, in terms of whatever. And you have a mechanism to represent all your company data in a way that can be iterated and can be leveraged together with this language model, right? Andrew mentioned RAG. RAG is a way of doing that, but RAG is not adding anything to the model. It's just, providing more context to the prompts, sending information to the prompt. I think, or I'm pretty much sure that enterprises, they're going to develop their own AI capabilities to develop differentiation, right? To gain kind of a competitive advantage. And for that, as I mentioned before, when I started, it's a cost benefits ratio, right? It's like, how is it to integrate my own data? How is it to run my own models? How much of a risk I take with this data that I put there? And for that, size matters, right? Performance, size, operational cost, the ability that I have to control the model. Grace mentioned also agents, and agents, the topic of the year for sure, but agents, they are going to be extremely costly if you have LLMs interacting with other LLMs, right? Especially when you add reasoning capabilities and you add the test-time compute inference. So it's going to be very, very, very costly, and it's going to be a nice exercise, but is it worthwhile pursuing that in the context of an enterprise when you are trying to hit some profits, right? So all these considerations, they need to be made. And let me add another thing, which I think is important. The ability to move from a model to an AI system. An AI system has more than just a model. For example, what we are doing in IBM, we are providing something called Granite Guardian, which is a way of putting guardrails so that you know that your model is behaving the way you expect, and you are kind of removing all the biases and risks and so on. And these guardrails that we put before sending the prompt and after getting the response from the language model, they are part of the same. So if you have a very large, costly model in between, this guardrailing is very, very expensive. So even if you want to really move from an AI model into an AI system, smaller models, they have advantages, right?
Thank you. I think there's certainly a cost-benefit analysis which needs to be carried out, and I think with respect to AI, probably a very abstract and understatement, something which is well known. There's certainly a fear of missing out. So you either have to be developing something or adopting a model, and I think often if it's deployed in the wrong way, then it could lead to some devastating consequences for organizations, especially if they're just looking to start by piloting it, let alone deploying it across business functions. So if you can deploy an SLM in a way which achieves those particular tasks you want to achieve, but it for a fraction of the cost, that's probably a good starting point for many organizations. So thank you for touching on that. I think the other sort of point I would sort of raise potentially is this point about fine tuning for niche applications. So I think in some ways SLMs could train and adapt for those industry specific tasks. I think we touched on medical diagnosis, but potentially also some legal automation compliance tasks. So yeah, I think definitely want to think about. So thank you for that. We're slightly ahead of time, which I think is always a good sign. So perhaps we can move on to the next segment of the discussion. We touched obviously on the opportunities, the advantages, the case for SLMs, but I think with any AI tool, there are some risks and challenges associated with that. So I might put the opposite question to the panel. What are some of the biggest challenges that you think, or pitfalls that businesses should potentially be aware of when working with SLMs, seeking to deploy it? And any sort of advice, especially for those potentially starting out. So Andrew, am I okay to go to you first?
Yeah, I think the one way of thinking about it is SLMs are almost the DIY approach to it. So there's a lot bigger overhead in terms of managing the models as well. So one of the advantages we haven't discussed yet is around the privacy aspect of this. So a lot of the time, one of the big advantages of SLMs is they are, I was going to say physically smaller, but they, in terms of gigabytes, some of them are like 2 gigabytes sort of size, which is downloadable onto a laptop, and some of the even smaller ones you can put on edge devices and smartphones, etc. So a lot of people are deploying these locally rather than on the cloud. The benefit of that is it gives you this privacy. And I've got a number of models on the laptop I'm actually using at the moment, and I can switch the internet off and still interrogate my model, even on a corpus of data I've got on my laptop as well. So I'm completely isolated from the outside world on that. And if confidentiality is a big issue for you, if you're a bank, if you're a venture capitalist fund, or whatever it might be, privacy is one of the big advantages of doing this. But so going back to the disadvantage, you now have to manage this model on your own environment, and it requires compute power. The updating of that model then is more difficult as well. So it's one of these double-edged swords, isn't it? In one side you've got OpenAI updating their models on a regular basis, and then you find actually whatever this nice chatbot that you built suddenly doesn't work because they've changed the way that the API works or whatever. You don't get that if you got your own SLM because you built it, but you have to make sure that it's kept up to date with the right information. But that just requires more technical capabilities within the organization. But as long as you've got that, then a lot of those issues kind of go away. But I think that's one of the well, I've kind of covered both the advantage and the disadvantage of it in that case. But I don't know if the panel want to kind of cover any of the others as well.
Yeah, absolutely. And I think, and thank you for mentioning data privacy and security. I think in some ways, perhaps it could spur further interest in, those particular areas. I think if you were to sort of deploy it on premises, it could ensure that data stays, in-house. And I think we also need to think about those, heavily regulated sectors. Think about finance, for example. So yeah, thank you for that. But yes, indeed, I'll turn to the panel and happy to open up to anyone who wants to go next.
Yeah, I'll go for no mind. So I think bias and hallucinations, that could be a challenge because these SLMs are trained on smaller data sets, smaller parameters. They may inherit bias from the data that's been used to fine tune them or to generate them. So I think validating those results and using a human in the loop, that's going to be key, especially in the public sector, which I operate in.
Thanks, Ed. Yeah, glad you mentioned human in the loop. Definitely important to mention that in any sort of AI webinar. Grace, I'll go to you next if that's okay. Same question about risks and challenges.
Yeah, I think it's funny when machine learning has been around for a very long time, and when you talk to machine learning engineers now, most of the time is spent on data quality challenges and data preparation still to this day. And I think that when we're looking at small language models, fine-tuning, management, being able to bring data over in order to fine-tune, there's a lot of other moving components and pieces that go into making that work at scale. We're not just talking about one, we're talking about multiple across a business. And so I think one of the risks is that it will go down the path of machine learning where 70 to 80% of the effort is just in preparation and data management and not actually building and managing the actual small models. And then I do think that this will, to Andrew's point about thinking about maintaining your own model, monitoring metrics, observability, this will also become a problem at scale. So how at scale can you understand how all of your models are working or get alerts when something isn't working? What should those metrics look like? How should we measure them? I think we're making progress in this space, absolutely, but there's still a long way to go, and we're still pretty nascent and making sure that we have the right tools and capabilities to support this.
Indeed, thank you. And I think that piece about agreeing on metrics itself is definitely something which I think a lot of organizations are grappling with. I think just given the fact that this particular technology is always constantly evolving, I think metrics are also evolving as well, and you're getting different ones sort of coming into existence. So thank you. Juan, I'll go to you next if that's okay.
Sure. I will comment along the lines of the other panelists. I mean, it's smaller language models that can be a blessing and a curse if not addressed properly. Just to summarize, there are probably two ways of kind of leveraging your own data with a large or a small language model, right? Which is like either RAG, as Andrew mentioned before, right? That could be even more sophisticated using cache and these CAG then. So there are many ways, but in the end, it's just accessing vectorized representation of your own knowledge, so that the language model can use that in the prompt, right? That's one way. The other way is like changing the model by doing fine tuning, right? The first, the RAG is very practical, but RAG does not add any new knowledge to your model, right? You are not doing much on your model, so you are always providing information from outside. While fine tuning does change your model, right? But you can lose generality, and you can what you end up is having a plethora of homemade models, and it can become very unmanageable, right? In terms of keeping them up to date, observabilities, like why is this model better than this one for this particular use cases? And then you think of complex organizations, right? This department here doing my own small model for A, and this other department trying to do the same for A plus B, and you have even conflicts. So it can really inherit the complexity of the human departments trying to do that. So I think what's really important is to put in place mechanisms so that you end up as a corporation, as an enterprise, having just one big version where everyone can contribute. And there are some techniques. For example, at IBM, we developed something called Instruct Lab, which has the benefits of the fine tuning, but without the complexity of managing many models. I think that's very, very important, because we will need to prove the case for Gen AI, right? And I don't think that we are there yet. So we are like in the exploration phase, but we need to enter into the exploitation phase, and that's yet to be seen how we go about that. Smaller models, they offer many benefits, right? As we hear from the panelists, in terms of cost, in terms of versatility, adaptability, and to me, we are going to see an emergence of even more focus on them because of agents. Otherwise, the agentic workflows, if really serving the purpose of implementing complex end-to-end tasks, because let's be honest, right? We call agentic workflows to everything that we could do kind of these days with the sequence of steps, right? But if we really go seriously about agentic workflows, we will need to also to watch for the advantages of smaller, more dedicated models. So to me, we have so the space for smaller models is there, but we need to be very careful not to inherit the drawbacks of the larger ones. And we need the right mechanism and the right research to make sure that they can really transform enterprises as we want.
Apologies for some interference from I'm just going to put you on mute. Thank you for that. I think I'll just add maybe one or two more things into the mix. I think certainly there's concern about bias and ethics, for instance. So if there is limited training data, that could give rise to bias, and I think that's where data set curation settings come into things. But also, I think in terms of scalability and versatility, so it may or may not be suited to, let's say, highly complex or multimodal tasks. So think that's certainly something to look out for. So thank you for that. We'll move on to the final segment before we get on to Q&As, and I think we've got a few questions into the chat. So I'll move on to use cases and examples, implementation strategies. This segment may be slightly shorter than the last ones, but I think I might just ask the panel, if an organization is looking to leverage small language models, what one piece of advice would you give them, and are there any sort of potential good examples of that? Would you say examples of best practice? So I think slightly covered in previous segments, but keen to maybe learn a bit more about that. Ed, am I right to go to you first?
Yes, I think our advice from a Databricks perspective is that it always starts from the quality of data. So if you don't have confidence in your data that it's reliable and that it's accurate, how can you expect the ML model to perform and the downstream value to be captured from deploying AI? So really it starts with a solid data foundation with the governance controls applied, and that will lead then, or that will be leading towards a successful deployment and adoption at AI. I mean, what we've seen with some of our customers in the public sector is some interesting use cases around the convergence of geospatial information and machine learning and aerial photography. There's an example in the UK where they're looking to map peatlands in the UK and then identify where in those peatlands using machine learning are those peatlands degrading or they're improving. In the UK, peatlands are a natural sink for for carbon dioxide. So here we have a very specific example in a government department deploying a model on their very specific data, but it leads to a countrywide impact for capturing and lowering emissions in the UK. And of course, it started with a very solid data platform where they could ingest this data at scale and deploy machine learning. So that's the longer answer, but yeah, it really starts with the data platform.
Thanks, Ed. Andrew, I'll go to you next, if that's okay.
Yeah, I can give you an example I'm working on at the moment, which is, I think, a really good example for one of the benefits of small language models. So I do a lot of work with the Natural History Museum, and we've developed a chatbot for their corporate services. So all the staff in the museums, they have over 1,000 staff, and we, using a RAG approach, we got about 180 documents, which are all the policies and procedures that the museum have around technology services, around HR, facilities, procurement, etc. They're all in this corpus data. We built this chatbot on Azure initially using GPT-4o, so the ChatGPT model, and that's deployed through Teams, so everyone has access to that. They just chat with it. How do I change my password? Where do I park if I've got a blue badge? All wide range of questions. That went in very successfully, and then staff started saying, well, we're the Natural History Museum, and don't these models use a lot of energy and water, and we're advocates for the planet? And so actually, that's a really good point. So we're now iterating that chatbot now to use a small language model. So initially we've gone down to GPT-4o Mini, which is still OpenAI, still a proprietary model, but now we're looking at even smaller models as well. So it's a case of taking it from the very capable, the Ferrari models, down to the maybe either 5.4, which is a model from Microsoft, or some of the others, but we're testing those at the moment just to make sure we get the right quality. But I think that's a really interesting story, because that's very much led by the organization saying, we understand now. And I think this environmental question is one for 2025. It's going to get much bigger as the year goes on. People are going to be much more aware of it, particularly around image generation, etc. But for the Natural History Museum, that's their world. So we're now looking at that. Kind of connected to that is this point. So in terms of advice, if you're implementing an application that's got some language model capability in it, you don't get many chances with people before they lose trust in it. So if you put in your first model and it's rubbish, it's going to be difficult to get their trust back again. So it's generally easier to start with the larger models, because that, you can get your mechanics working, that's fine, and then start to reduce it down, and because that's then in your control, and they can, you can keep testing it, but at least they got something that works, and they know that it is capable of doing this. You just go as small as you can before you start to lose some of that accuracy or latency.
Thanks, Andrew. And yeah, certainly keen to learn a bit more about that particular use case that you're working on. So thank you for sharing your thoughts in relation to that. Grace, I'll go to you next, if that's okay.
Yeah, also at Snowflake, absolutely, it does come down to data quality. But I think my biggest piece of advice would be to start with a very clear, well-defined business use case. So oftentimes with Gen AI, what does success look like? And so if you start small, not just in model size, but also thinking about a really clearly defined business problem, then you have a better way to say, okay, yes, it's performing as expected and it's meeting what we need, or it's not, and moving on from there. And I think, there's obviously a lot of technical judgment and evaluations that come in, but winning that value with a smaller model, I think would be definitely a very good place to start to win both trust and adoption, and then grow on from there.
Brilliant, thank you. And I think certainly reinforces the need to ensure that organizations do ensure that, the tasks that AI is completing for them aligns with their business objectives. I think if you really want to develop a meaningful proof of concept, it's really important to make sure, as an organization, you identify a problem first and then apply AI to solve that, rather than, deploying AI to, identify a random problem for you. So thank you for that. And Juan, I'll go to you.
Well, I think to build upon what Grace said, which I think is completely on point, right? In terms of, don't think of the model to create a poem about your favorite football club. So think of a business problem that you want to solve to achieve differentiation, right? So it's very, very important to think of AI in the context of a business that you want to achieve. That's one thing. The other thing is, like, also never forget that your source of differentiation is your own data. So it's very important to incorporate your own data into your AI use case. Very, very important, because otherwise everyone can do what you do, right? Okay. Third, when you think of deploying your own models for your company, so to leverage your own data, it's important that you trust the small model you are building upon, right? It needs to be transparent. It needs to be. I'm a big fan of, and we at IBM, we push for open source. We think that open source is really catching up, and open source brings a lot of advantages versus proprietary frontier models. So if your model should be performant, open, trusted, right? You need to have the security that you can build upon this model, for which if something goes wrong because of the data this model was trained on, you should ask for indemnification, right? So the model producer should indemnify you if they infringe copyright or whatsoever. So that's very important when you build upon a model. Make sure that you think of your own data to differentiate yourself, and think of the overall operations, not only the building the model, but the operations on top of the model, which includes, for example, where, at which cost to run inference, right? We at IBM Research, we are developing a specific hardware to optimize so the inference part, not the training, the inference part, because it's kind of the probably the most used phase in the lifecycle of a model, so that you don't have to rely on very, very expensive GPUs. You can do the same at a fraction of the cost and the fraction of the energy consumption, right? Those would be my advices to really put the language models, the smaller language models, to work in the context of an enterprise.
Thank you, and yeah, I do appreciate you touching on that open source point. I think there's certainly some interesting opportunities stemming from that. So thank you. We're ahead of time, which is good, which means we can probably wrap up this segment and move on to Q&As. I think we've got one in the chat, which we'll certainly take. But if you have any questions, please do flag them now, and we'll happily put them to the panel. So yeah, over to you for any questions in the audience. Okay, no worries. In that case, maybe I'll put this one question to the panel now. So this is from Jonathan Scott. So would the panel like to comment on the dangers of training SLMs with content that has also been generated by AI in a large language model, the possibilities of hallucinations, degrading the qualities of SLMs? And I think you said, I heard a great quote recently of this being the digital AI equivalent of a mad cow's disease. So I'll hand over to the panel, and keen to hear any thoughts of whoever wants to maybe take that one on first.
Mm-hmm.
I mean, there is definitely a risk in this. It's maybe another analogy is, when you're making a photocopy of a photocopy of a photocopy, you're going to get degradation of quality there. But with all of these, it's around, and all language models are essentially black boxes. It's difficult to understand what's happening in those. So the only way you can really understand whether it's going to work for your particular use case is through testing. And if you're using an SLM that's been trained on synthetic data or through distillation, then if it works for you, then great. Don't worry about it. If you're finding it is hallucinating too much or you don't get the accuracy, then don't use it. I think that's the simple advice on that.
I can talk a little bit about synthetic data is a really interesting problem in the space right now. Part of that reason is because as we talk about evaluating model output and responsible AI, so fairness, bias in your model outputs, which is especially important when you're, per se, a public institution. You need to make sure that you can account for a variety of different use cases and different interaction styles, outputs, etc. And so where synthetic data can be really helpful is augmenting data sets to provide additional diversity with data that's traditionally very challenging to capture. So in that sense, it's not just train all on synthetic data or not, but I would argue that there is definitely a rising place in using synthetic data for training to make models better, more resilient and robust.
Yeah, if I may add also some insights on that. First of all, that's a very thriving research area, right? Andrew mentioned distillation, and obviously you can inherit from the teacher model, you can inherit some of the biases and of the hallucinations and so on. There's some research pointing out that smaller models, they are not so, well, they don't suffer from a hallucination so much if they are kind of distilled or trained from scratch with the right data and the right mechanism. But again, it's just an open question. I think what's really important is to think of what I said before, from a model into an AI system where you can put guardrails around the model, right? I think guardrailing helps instead of just trying to put all the responsibility on the model itself. So that's something that works very well with SMLs, so SLMs. And to the synthetic data generation point, it's funny because right now we are running out of data not being generated by Gen AI, right? So this data cannibalism can pose many problems. And in order to help train the next generation of models, we really need to generate some synthetic data. But then it becomes a chicken and egg problem, right? What's important here, I think, is the to advance the research in terms of synthetic data generation, which I think many institutions are doing on one hand. On the other hand, which I want also to highlight a point that is very important. Large language models or models in general, they turn to learn also the benchmarks. So we try to adjust the quality of a model by establishing independent benchmarks. But guess what? These models, they see also these benchmarks, and they learn how to trick the benchmark. It's like you were studying for an exam, and you've been given the questions up front, right? That's a bit of the problem that we are having these days. So I think we will also experience a lot of research in terms of how to, for real, establish ways of benchmarking the knowledge or the ability of smaller or larger language models. Yeah.
Thank you. So some interesting points. I'm glad that we've sort of gone on to this topic of synthetic data, which I think in itself could be another webinar. And I think that, I think obviously there were some concerns about it giving rise to, proxies which contain biases, but I think the key point is, synthetic data is there to complement existing data sets. It's not there to replace. And I think obviously making sure that you have the right sort of infrastructure in place to do so. So thank you for covering that. I think a few more questions in the chat. I think we've got time for one or two. Any views on RAG using small language models as opposed to RAG using large language models? I'll put that to the panel for any thoughts.
I can start. Again, I think it's a use case piece. There may be use cases where only an LLM will do. If you've got a large corpus of data with complex documentation in it, then maybe it needs an LLM. But SLMs will, in most use cases, will be good enough on that. But again, it's just around testing between the two. I've had the applications I've built for clients, generally the SLMs, like the ones in like the tens of billions of parameters, so not the tiny ones, not the 1 billion etc. or less than that, but the 7 to 20 billion parameter models do a good enough job, because you've got your RAG which helps you focus your model's answers, and then you've got the ability for prompt engineering between that as well, and the combination of the two should give you the performance you want. And then the other piece is the fine tuning. And I'm not sure we've kind of scratched the fine tuning itch enough on this yet. We've mentioned it a few times, but the benefit of fine tuning is it alters the weights of the model. So RAG, as Juan said earlier, the model doesn't change. It's just using that information to supplement its knowledge. With fine tuning, you're changing the weights of the model either completely. So if you do a full fine tune of the model, you can change the whole model, or you can use what's called a LoRa, which is just changing some of the low ranking weights, and it's kind of giving you a little wrapper that personalizes to your particular domain. So if you've got that and the RAG and the prompt engineering, I think then you should have very low hallucinations, if not zero, and very accurate answers out of it. It's just whether you can you want to go through that process of fine tuning is not an unsubstantial task as well. The data set you use needs to be very good, and there's a chance of overfitting as well. So a bit like the LLM seeing the answers to the benchmarks. If the small language model is too small, it's just going to learn exactly the data you've given it and not being able to generalize enough out of it. So there are risks around that, but the advantage of using the open weight models is that you can fine tune them and get some better results out of it. You can, just to kind of complete the circle, you can fine tune the proprietary models, with like the OpenAI models, but you pay them quite a lot of money for the privilege of that, and they're hosting that model. You're going to pay more tokens, etc. Whereas if you're doing it yourself, it's a one-off exercise. It might take a few hours or a day to fine tune using GPUs, but once it's done, and then you're kind of away.
Thank you. Any additional thoughts from the other panelists on that, or should I move on to another question? Yeah. Okay, fab. A question regarding explainable AI. So do small language models play a role in explainable AI? I think it's a really interesting question. So I'll put that to the panel and keen to hear any thoughts.
I can start. I saw another question too about rubrics and agentic AI, and so I'll kind of combine the two. So rubrics can be used in agentic AI. They're often the guiding operation decisions between one agent interacting with another agent. So sort of that guardrail of how and when they should interact. And one of the really interesting things about using that kind of daisy chaining of smaller models is that it offers us the opportunity to do a step-by-step evaluation and explainability check along each small piece versus just waiting till the very end to evaluate the output. So as we're shifting towards more precise understanding of accuracy and that trust that you want at the output. When you're using multiple smaller models, it's easier to get to one final piece. It's easier to have those stops along the way for things such as human in the loop or additional more defined information that's surfaced. So I think the two are definitely interrelated, and I think as our demands around explainable AI, given regulation, given consumer trust, business risk, managing business risk, privacy concerns, all of these as they start to become more and more in the forefront of technical decisions that you're making. So there's the business saying we want to do this, and then there's the technical team thinking of what the implications are for their architecture, and smaller models will become potentially a piece of that puzzle.
Thanks, Grace. Any other views from the other panelists in relation to that? Juan, do you want to jump in?
Just to kind of add something that I think is relevant. SLMs can be also trained to help us understand LLMs, right? Or to help us put some guardrails around. That's how for example, we've done with Granite Guardian. So they do play a role in terms of shedding some light in terms of how other models are done, are performed, are trained. That's one thing. And I would like to also to pick up on another question here in the chat that I saw. It's like, where is it? Here. Any views on if we are better off using traditional AI models for use cases like prediction or forecasting, or fine-tuning smaller or bigger models and so on? I think this question is very, very important and ties back to actually what we said before, business context, right? Enterprise context. Before joining IBM, I was the chief data officer for E.ON, and we've been developing bespoke models trained for a particular purpose, and they were working very, very well. And to be honest, they do have a place, and they do have kind of the right to exist, because they do something very, very well, and you don't need the complexity of having a big model, fine-tuning, looking at how you use that and so on. Having said that, let me offer a different perspective. Sometimes these bespoke models, they lack, apart from being more data hungry, more labeled data and so on, they lack of the ability to generalize. That's something that we've seen, for example, training in a different modality, not language, our geospatial foundational models with NASA. So what we see is like, if we fine tune, for example, for a particular task, like detecting the impact of a flood, right, in a particular area of the planet, our fine-tuned model generalizes all across the Earth. Why? Because it's been kind of a fine-tuned on top of the existing overall knowledge of the Earth that the foundational model has seen. While bespoke models, while maybe performing very well in a particular area, they oftentimes lack the ability to generalize. So there are many aspects to be taken into account, but the answer to me is yes. If you have a very particular purpose, don't try to use kind of a hammer to solve all your tasks. Use that for what it is meant to be.
Thank you. Any other thoughts in the panel on that question, or shall we move on?
Well, yeah, I just, I mean, I've been working in maybe like the rest of the panel in AI for many years, at least 10 years now. way before the days of LLMs and traditional prediction models and forecasting models and clustering, etc. That was what we did, and there's still so much value in all of that. And I spend half my time reminding people that all this AI still does exist and is really, really valuable, and it's not just ChatGPT. So just to make that point, I had the opportunity to make that point today, because it's there's so much good stuff that you can do with data-led AI there.
Indeed, thank you. We're at 5 minutes past. I'm conscious of time, so perhaps we can wrap up and end this session. I want to thank the panelists for joining me for this really insightful discussion, which certainly could have continued. For our next session, we'll be looking into open source. So the AI Leader Series will certainly continue, and would encourage all of you to attend. This session, as I mentioned from the start, is recorded, so it'll be on our YouTube page momentarily. I do want to flag a few things into the chat before I do sort of end the session. So we have this AI Hub, which at techUK brings together our work on numerous work streams spanning adoption, but also ethics and safety and AI skills. And I also wanted to flag that we have now opened submissions for AI Campaign Week. So if you are a techUK member, do check this out and submit content where possible. So yeah, many thanks for that. And I would like to obviously thank the panel, to thank Grace, Ed, Andrew and Juan for what has been a really insightful discussion. Please do add them on LinkedIn if you'd like to. But on behalf of techUK, thank you to the panel, thank you to the audience, and we look forward to no doubt seeing you soon. So thank you very much for your time and enjoy the rest of your day. Thank you.
Thank you, everyone.
Thanks, everyone. Cheers.
Bye.
Cheers.
Thanks all. Bye-bye.
Okay.